30 nickels, dimes, and quarters whose value is $4.50. That's 2 facts right there. Actually, if you consider the types of coins, it's 3 facts. So nickels, dimes, and quarters are the types of coins we're dealing with here. So let's start with that. Nickels, dimes, quarters. One of the facts they've given us is how much money we have. The other fact they've given us is how many there are. So each fact is going to help us create an equation. Since we have 3 unknowns, we have to make 3 equations. I'm going to set up unknowns. Number of things is going to be n nickels, d dimes, and q quarters. So how many nickels do you have? 6. N equals 6. That's what we're looking at here. Value, we're going to do in cents. Every nickel is worth 5 cents. We have n of them, so 5n represents the amount of money we have in nickels. Every dime is worth 10 cents. We have d of them, so 10d is the amount of money in dimes. Every quarter is worth 25 cents. We have q of them, so 25q is the value of money in quarters. Looking at fact number 1, the fact that we have 30 coins. 30 is a number of things. We go with the number of variables. The number of nickels plus the number of dimes plus the number of quarters is equal to the number of coins. The value of the nickels plus the value of the dimes plus the value of the quarters is equal to the value of all the money. All the values here are in cents. This value is in dollars, so we need to move the decimal point 2 spaces to the right to make sense, so 450 cents. And usually with these coin problems, 5, 10, 25, 450, everything divides by 5. So if I do that, I get n plus 2d plus 5q is equal to 90. Third fact, there were twice as many dimes as nickels. Now be careful with some number of times as many when you see a statement like that. If I just start off with the d equals n, which is false. Pay close attention to the words here. Twice as many dimes, that means more dimes than nickels. So looking at these 2 variables that we have no idea what the values are, I know for a fact d has to be bigger than n because there's twice as many dimes. Twice as many dimes, more dimes. So I've got to multiply a number by 2. I can either do 2 times the bigger number makes a smaller number, or 2 times smaller makes bigger. Makes more sense to do 2 times the smaller. Twice is very close to the word dimes. People sometimes get confused there and want to do 2d. So be careful with that. It'll be similarly stated on the test, so be careful with that statement. All right. And now that we've got all 3 facts listed, easiest way to do a system of 3 when we have a statement like this is to just substitute. So change this d to a 2n and change that d to a 2n. So if I do n plus 2n makes a total of 3n plus q is equal to 30. And if I do n and then 2 times 2n is going to be 4n. Again, d equals 2n. 2n times 2 is 4n plus n is a total of 5n plus 5q is equal to 90. Now that d is out of the picture, I've got an nq equation. I could multiply the top equation by -5 to get rid of the q's. I also noticed, though, that 5n, 5q, and 90, everything divides by 5, so n plus q is equal to 18 would be equivalent. At this point, changing all the signs in the bottom equation seems to make sense to me, so I go minus n minus q minus 18. 3n minus 1n is 2n. Q minus q cancels. 30 minus 18 is 12, so n equals 6. If I go back, we know n plus q is equal to 18, so 6 plus q is equal to 18. Therefore, q has to equal 12. And we also know that d is equal to 2 times n, so d is equal to 2 times 6, so d will equal 12. So we got 6 nickels, 12 dimes, and 12 quarters. Number 2, the sum of the digits of a 2-digit counting number is 8. Okay, so let's start off with this. The 2-digit counting number is going to be structured in this manner. Some tens digit plus some units digit. So the digits are t and u. If they're talking about the digits, we're just going to use t and u. If they're talking about the number is going to be 10t plus u. This is the original number. They a lot of times like to reverse the digits in the number, so the reversed number, if I swap the digits, that puts the units digit in the tens place, the tens digit in the units place, so the reverse number is going to be 10u plus t. So those are the types of relationships they're going to do to give me the facts to create the equations. They're going to talk about the digits. I use the letters T and U to represent that. They're going to talk about the number, the original number, 10t plus u, or the reversed digit number, 10u plus t. So looking at the facts, the sum of the digits is 8. Sum of the digits, talking about the digits themselves, we're talking about t and u. Add the tens digit, add the units digit, we get 8. Fact number 2, if the digits are reversed, the new number is the reversed number, so that's 10u plus t, equals 18 less than, we always ignore less than, greater than until the end, the original number. The original number is 10t plus u, and it tells us that the new number is 18 less than. So equals 18 less than happens after the word equals, so minus 18 goes over on the right hand side. I would probably move the 10t and the u to the left, so 10t moves over minus 10t, u moves over minus u, 10u minus u makes 9u, t minus 9t makes negative 9t, and negative 18. And everything divides by 9, so u minus t is equal to negative 2. If I swap the position of these two letters, so they line up with these, this is going to be u plus t is equal to 8. And just like that, we've got a really simple system of equations. U plus u is 2u, negative and positive t cancel, negative 2 plus 8 is 6, so u must equal 3. The digits add up to 8, 3 plus 5 is equal to 8, so t must equal 5, so we get 53 as the number, which is what they're asking for. Number 3, Fabian took 2 times as long to fly 1,200 miles as Hamilcar to fly 1,000 miles. Find the rates and times of both. Hamilcar's speed was 200 greater than that of Fabian. So they tell us both their distances, no pictures necessary here. Our characters are Fabian and Hamilcar. I don't know who came up with the names, I copied out of the book. So Fabian flew 1,200 miles. And Hamilcar flew 1,000 miles. Okay, now we need to start looking for facts about things, facts about rate, facts about time. So let's start with the time. Fabian took 2 times as long. All right, so again, you got to be careful with this. Who's got more time? So Fabian's flying for a longer amount of time. So if Hamilcar's time is t, Fabian's time is twice that, so 2t. It also tells us Hamilcar's speed was 200 greater than that of Fabian. So Hamilcar's speed's faster by 200. So if Fabian is going some speed r, Hamilcar is going 200 faster than that. And just like that, I got my rates filled in with the same letter. I got my times filled in with the same letter. I know my distances. And the relationship between rate, time, and distance is that rate times time is equal to distance. So 2RT must equal 1,200. And I can simplify that to RT must equal 600. I can also see from this, if I distribute, I get RT plus 200T is equal to 1,000. And there's my system of equations. That one made this one, and then these are the two I'm going to use. And the expectation you should have is that this expression will be present, so we can do a substitution directly in there. So RT is equal to 600. We take the RT out, put 600 in. 600 plus 200T must equal 1,000, which means that 200T must equal 400, which means that T must equal 2 hours. Okay, so then as far as the answers are concerned, I've got Fabian's rate, I've got Fabian's time. I've got Hamilcar's rate, I've got Hamilcar's time. So, T, if I go back to my picture here, T represents Hamilcar's time. So T sub h is 2 hours. I can also see that Fabian's time is double that. So if this equals 2 times 2 makes that equal 4. So Fabian's time must be 4 hours. The other thing, I need to figure out what R is, okay? I can go either place to figure out the rate of each of these people. So I've got these expressions here. I'm just going to erase this and this, just to kind of show you as you get more information, you don't need to have all these structures over here anymore. I know that rate times time is equal to distance. So if I put 300 times 4 makes 1200, because it does. And that means that Fabian's speed is 300 miles per hour. I also know that 500 times 2 is equal to 1000. So a Hamilcar's speed is 500 miles per hour. Could have also used the relationship that Hamilcar's speed is 200 greater. Wants to figure that out. 300 plus 200 is 500. So again, as you get more information, you can figure out your answers wherever you want to. But if I already know the times and I know the distances, distance divided by time equals rate. 1200 divided by 4 is 300. Distance divided by time equals rate. 1000 divided by 2 is 500. So there's all my answers. You get an answer, use that answer to fill in something. And again, I like to use a relationship to get the time, and then once I know both of these, I divide. Or if I happen to find R first, then I find both of these, and then I divide to get those. That's what I would do. Number 4, graph on a number line. So we have a quadratic inequality here. First priority on a quadratic inequality is you want greater than or less than 0. All right, so it's already ready to go. Once you get to that point, you have a quadratic over here, you're going to want to factor. So negative 4 times 1, negative 4 plus 1. So x minus 4 times x plus 1 is less than 0. Then I'm going to find the zeros. The zeros are x equals positive 4 and negative 1. What value of x makes each factor 0? So 4 minus 4 is 0, so x is 4. Negative 1 plus 1 is 0, so negative 1. And then what I do is I set up intervals for those two things. We start at negative infinity. We work our way up to positive infinity. Anytime I get to a 0, I got to stop along the way. So my first interval goes from negative infinity to the smallest number, which is negative 1. This inequality is a less than inequality. There's no equals to it, so I'm going to put a parentheses. Parentheses means we don't want to include a bracket. If I bracketed it, that means I do want to include negative 1, but there's no equals to, so I don't want to bracket that. The next interval goes from that same number, negative 1, up to the next biggest number, which is 4. I've run out of numbers, so my final interval goes from that number 4 up to infinity. Again, I'm putting parentheses in every interval. And again, this is just something between negative infinity and negative 1. Something between negative 1 and 4. Something between 4 and infinity. That's all those intervals mean. Then I'm going to pick a number within those intervals. So pick a number between negative infinity and negative 1. I'm going to pick negative 2. Between negative 1 and 4, I'm going to pick 0. Between 4 and infinity, I'm going to pick 5. These numbers are what are going to be x in this picture right here. And that picture right there, it's very simple. Less than 0 means negative. That's what that means. We're looking for a negative product. So if I put negative 2 in place of x, negative 2 minus 4 is negative 6. All I care about is the sign. Negative 2 plus 1 is negative 1. All I care about is the sign. If I multiply two negatives, I'm going to get a positive. I'm looking for negatives, so that's not a correct interval. Next number is 0. I'm multiplying two numbers. 0 minus 4 is negative 4. All I care about is the sign. 0 plus 1 is positive 1. All I care about is the sign. Negative times positive makes a negative. Negative is what I'm looking for, so that's a correct interval. The final interval here, 5, is our test value. 5 minus 4 is positive 1. All I care about is the sign. 5 plus 1 is equal to 6. Positive, I care about is the sign. Two positives multiply make a positive. I'm looking for negative, so I throw that interval out. So the answer is everything from negative 1 to 4. So if I was just graphing over the set of real numbers, negative 1 not included to 4 not included, shade, that'd be the graph. Okay? But we can clearly see here they're not asking me to graph real numbers, they're asking me to graph integers. Looking at the integers that I actually got graphed on this shaded in thing, I didn't graph negative 1 or 4, but I did graph 0, 1, 2, and 3. So when you're not including the endpoints, all that happens is you don't have to put open circles, you just don't start there. So negative 1, but don't write anything. 0 is between negative 1 and 4, 1 is between negative 1 and 4, 2 is between negative 1 and 4, and 3 is between. Negative 1 and 4 aren't included because there's no equals to. If there had been an equals, then there would be an equals, then there would be a bracket and a bracket. If there's brackets, we're going to shade in those numbers too. Okay, there wasn't, so we won't. So just be ready for any option that I throw at you. If this had said greater than 0 instead of less than 0, then both of these would have been correct. This would have been wrong. So the technique's the same whatever they ask you for. It's just a matter of answering the question they're looking for. So we're looking for less than 0. We're looking for negative. That's what we graph. If this said greater than 0, we're looking for positive. These are positives. That's what we would have graphed. Number 5, same exact type of problem. I'm going to go through this one a little quicker. This time domain is a set of real numbers, and it's already factored for us. It is greater than 0 this time, so again, this time we're looking for positives. So, x equals positive 1 and negative 4 are the things that make each of these factors equal to 0. So that's going to help me set up my intervals. And I'm going to start at negative infinity, go up to the smallest number. I'm using a parentheses again because there's no equals to, so we use parentheses. Negative 4 up to 1, parentheses, parentheses, and 1 to infinity. Just like before, I want to pick test values on each interval, something in between these values. So between negative infinity and negative 4 is negative 5. Between negative 4 and 1, I'm going to pick 0. Between 1 and infinity, I'll pick 2. And again, all I'm doing is I'm evaluating this product that is right here to see if it's positive or negative. Positive is what I'm looking for. Negative is what I'm not looking for. So if I get positive, I keep it. If I get negative, I cross it off. So put negative 5 in. Negative 5 minus 1 is negative 6. Negative 5 plus 4 is negative 1. Multiply two negatives, you get a positive. We want positive. That one's a good one. Put 0 in. 0 minus 1 is negative 1. 0 plus 4 is positive 4. Multiply a negative times a positive, you get a negative. That's no good. Put 2 in. 2 minus 1 is positive 1. 2 plus 4 is positive 6. 2 positives make a positive. That's a good interval. So both of these intervals survived the test. And we're graphing on the set of real numbers this time. So we're going to graph, again, negative infinity lives all the way down here. Positive lives all the way down here. So if I'm going from negative infinity to negative 4, I'm stopping at negative 4, but I would have started at negative infinity. So I shade the arrow to demonstrate that. Open circle, because again, it's not included because there's no equals to. 1 to infinity starts at 1, not including 1, and goes towards infinity. And then we shade that arrow in, and there we go. So pay attention to the domain. If it's integers, dot, 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 dot. If it's real numbers, open or close circle, and then shade the right direction. If it had been this one, it would have been open, open, shade between. If it goes to infinity or negative infinity, just make sure the arrows get bolded in to represent movement down to that value. Number 6, multiply. And all we have here is just a basic FOIL technique. I'm going to slide this down so I have room to draw some arrows. So FOIL is first times first, and we have to remember our rules of multiplication of letters. So if I'm multiplying x to a power times x to a power, the rule says to add the powers. Alright, so that's what's happening here. I'm multiplying x times x. I'm going to get x. 1/2 plus 1/2 is 2/2, better known as 1. Outside product. When I multiply different letters, all I can do is stick them together. That's a positive being multiplied by a negative, so it's negative. X is to the half power, y is to the first power. Inside times inside. Again, different letters. Positive times positive makes a positive. All I can do is put them together. X to the 1/2, y. I like alphabetical order. Y x to the 1/2 is also correct. And then last times last will be these two. Positive times negative makes a negative. Y times y is 1 plus 1 makes y squared. So we end up with those 4 terms. If there's no like terms, we're done. If there are like terms, we have to combine them. Very clearly we can see x to the 1/2 y are the same. That's minus 1, that's plus 1. Cancel, cancel. So we're going to get x minus y squared as the best answer for that. Had they been the same sign, 1 plus 1 would have made 2x to the half y. So in this case, they were opposites, they cancel. Number 7. We have an absolute value inequality problem. First step of an absolute value inequality problem is solve for the absolute value expression. So I'm going to move the 2 to the other side. That gets me negative absolute value of x is less than or equal to negative 2. I want it to just be absolute value of x, so I'm going to change it to positive absolute value of x and change that to positive 2. Changing both signs requires a flipping of the inequality. Equals stays equals. If it wasn't equal, it stayed not equal, but this one has an equal, so it stays on there. That's priority 1. Get to this point, keeping the absolute value expression there. Okay. Now, the next step is we want to get rid of the absolute value expression. We want it to just be x. So the two possibilities that are going to happen is either going to be greater than or equal to 2, in which case we're going to do what we're about to do here, which is x is greater than or equal to 2. Just pretend they aren't there, what everybody wants to do anyway. Then you write the word or, and then you write x and then less than or equal to negative 2. So x, whatever the expression is there, and then exactly the same thing, flip and change a sign. The other scenario that could have happened would be absolute value of x, let's say, is less than or equal to 6, something like that. That would be negative 6 less than or equal to x less than or equal to positive 6. So if it's less than or equal to, it creates this picture. If it's greater than or equal to, it creates this picture. Create the right picture. Then we simply have to graph those on the same number line. Domains instead of real numbers, x greater than or equal to 2 would be starting at 2, closed circle, because the equals 2, shaded to the right, arrow is included. X less than or equal to negative 2 starts at negative 2, closed circle, because the equals 2, and shaded to the left, because less than is to the left. We shade the arrow to show that it goes on forever. Number 8. To determine if something's a function, a set of ordered pairs specifically, we first of all look at the x-coordinate of each. So we have 1, 2, 3, 4. If they are all different, the answer is yes. Simple as that. If for some reason I gave you the same number, let's say I gave you this set of ordered pairs, 4, 5, 5, 7, 5, 6, 6, 9. Say you give me that. All right, so again, looking just at the first numbers, 4, 5, 5, 6. Now we have same. Same. Now we got to look at these two guys. If those two guys are different, the answer is no. Okay. Had I had the same exact scenario, but this had been a 7, so 4, 5, 5, 7, same is still a yes. All right, so those are the things I can do with a set of ordered pairs for you. Either they're all going to be different, it's immediately a yes, or you might get a same. If you get another same, so the same x's and the same y's, same point, still a yes. Same x's, different y's, now they're different points, it's going to be a no. So that's the check that you need to do for that one. Number 9, find the numbers 1/7 away from 4 1/3 to 9. So we're going to start at 4 1/3. We're going to go 1/7 of the way from 9 to 4 1/3 to 9. Okay, 9 minus 4 1/3 is the directional distance. So if I do this minus that, that gets me exactly how far it is and in the right direction. So we're going from small to big, so we're going in a positive direction. This will be positive, and that's the exact distance between. We multiply that distance times a 7th to get exactly how far we're going to move, and we add that movement to the beginning number. That's what's happening here. That's the structure that we want to create. I see mixed numbers. I don't like mixed numbers to work with in an expression, so I'm going to change everything to improper fraction. 4 1/3 is 13/3. Alright, so 4 1/3 still 13/3. The fact that I'm subtracting here makes a common denominator necessary. So 4 1/3 13/3. I can't make that anything but 13/3. So I'm going to make 9 into 27/3. 27 minus 13 is 14. 7 goes into 14 2 times. And 13/3 plus 2/3 is going to be 15/3, which equals 5. No guarantees that it's going to come out nice and pretty on the test like that. But that's what this one is. Seems like not big enough to me. 27 minus 13, 14. That's what it came out to. So, number 10. Find the equation line through 3, 5 that is perpendicular to that line. So, let's start off with this. Anytime we're told to find the equation line, we want to find the slope. And you have to look at the information in the problem to establish how you're going to find slope. When it says perpendicular to a given line, we're going to find the equation line in slope-intercept form. So, x plus 2y minus 7 equals 0. Which means that 2y is equal to negative 1x plus 7. I like to put numbers in front of x if there isn't one. So x moves over, becomes negative, and it's negative 1x because it's positive 1x here. Minus 7 moves over, becomes plus 7. 2y stays where it's at, stays positive 2y. Divide by 2, divide by 2, divide by 2. We end up with y equals negative 1/2 x plus 7/2. Then, the slope of that is negative 1/2. So the perpendicular slope, because that's what it tells us very clearly here, perpendicular. So the slope of the line they gave me is negative 1/2. The perpendicular slope is going to be positive 2/1. To make perpendicular, you change the sign and you flip the fraction. So negative becomes positive, 1/2 becomes 2. This is the slope of the line we're actually looking for. So all this work, very necessary work, got me the information I'm looking for. Once I get the information I'm looking for, the actual perpendicular slope, you might even want to strike all this stuff out because at no point in time from this point forward is going to matter. All that needed to be done to find that number so we can get the number we actually need. Once we get the number we need, all this stuff is irrelevant. Don't even consider it anymore. So now we're looking at this to find the equation line that passes through 3, 5, whose slope happens to be positive 2. So now we go to y equals mx plus b. This is x, this is y, this is m. So y is 5, m is 2, x is 3, b is unknown. 2 times 3 is 6. Move the 6 to the other side, we get negative 1 equals b. So our slope is 2, our y-intercept is negative 1, our equation is y equals 2x minus 1. This is always the structure of your answer. Make sure m and b both get replaced. Make sure x and y stick around for the ride. Then you end up in the final answer. Number 11. We got a fractional and decimal system of equations. Our first process here, I would get rid of the fractions and decimals. So multiplication by 4 on the top equation. 4 times 1/2 is 2 times x is 2x. 4 times 1/4 is 1 times y is 1y. And 4 times 7 is 28. Be careful that each object, even the fractions and the non-fractions, get multiplied by that 4. Reducing fractions with the number first and then multiplying. For the decimal equation, 2 decimal places, 2 decimal places. Stick a 0 on there so it's 2 decimal places. Everything's the same number of decimal places. Then you just drop the decimals. So I'm going to get 70x minus 2y is equal to 388. And now I've got a much simpler looking system of equations. My options here, I can multiply the top equation by 2, the y's will go away. But I could also divide the bottom equation by 2, the y's will go away. So take your pick. My guess is most people would notice the times 2 more. So I'm going to do times 2 on the top. So that's going to get me 2 times 2x is 4x. 2 times y is going to be plus 2y. 2 times 28 is 56. 70x plus 4x makes 74x. Negative and positive 2y cancels. 388 plus 56 is 444. And if I divide both sides by 74, I get x equals 6. Once I know what x equals, I go back to any equation. I think that blue equation looks a lot more friendly than the red equation. The numbers are a lot smaller. So x equals 6, we just figured that out. So this whole thing, 2 times 6, is going to become 12, plus y is equal to 28. 12 moves over, that gets me y is equal to 16. So 6 for x, 16 for y. Always write your answers in ordered pair when you do a system of equations. Number 12, system of 3 equations, 3 unknowns. I can get rid of x, y, or z to begin with. Your choice, doesn't matter. Just looking at it, y minus y cancels very easily. Y minus y cancels very easily. I'd probably get rid of y. So if we add the 2 top and bottom ones together, the blue ones, x plus 2x is 3x. Y minus y cancels. Z plus z is 2z. And 1 plus 0 is 1. If I add the red pair together, 2x plus 3x is 5x. Negative and positive y cancels. Z plus z is plus 2z. And 0 plus 7 is 7. So we create this nice little system of equations with just x and z in it. Forget about y for a few minutes until we get x and z figured out. I notice here right off the bat, 2z, 2z. So if I just change the signs, let's make that negative 3x, negative 2z, negative 1. Every single sign changed. Negative 3x and 5x makes positive 2x. Negative and positive 2z cancel. Negative 1 plus 7 is 6. Divide, we get x equals 3. I go back to, let's say, the blue equation that says 3x plus 2z is equal to 1. That's our original blue equation. We just figured out x equals 3. So this term, 3 times 3 becomes 9. So 9 plus 2z is equal to 1. Move the 9 over, subtract, we get 2z is equal to negative 8. We divide by 2, we get z is equal to negative 4. Now I know x equals 3, z equals negative 4. I go back to one of these equations, I like this one up here. We know what x equals, we know what z equals, we have no idea what y equals, that's what we're trying to find. So x equals 3, plus y we don't know yet, plus z, so it's plus negative 4, which is minus 4 is equal to 1. That makes y minus 1 equals 1, 1 over plus 1, y is equal to 2. So we figured out x, y, and z, so we're going to write our answers in order triple. X goes in front, then y, then z. Make sure you write your answers in order triple on a system of 3 equations. Number 13, simplification. The first step of simplification is make each individual term as simple as possible. Do that first. I to a power bigger than 1 is a problem, so this has to be fixed, and this has to be fixed. Radicals need to be fixed also, and specifically, negatives inside of radicals need to be fixed. So each one of these things has issues. So the first thing I'm going to do before I even worry about the fact there's i's in the denominators, I'm going to make everything as simple as I possibly can. So let me start on the denominator. And negative inside a radical makes an I. So I times the square root of 2 times I times the square root of 2. I times I is I squared. Square root of 2 times square root of 2 makes 2. I squared is negative 1 times 2 is negative 2. So that green term goes from here, take the negatives out to create i's, multiply the i's, get an I to a power, multiply the radicals to get rid of the radical in this case, and then we get negative 2 just out of that. We move on to the purple term. It does say minus, I'm going to keep it minus. The negative in the radical creates an I in the square root of 25. The square root of 25 is 5. And I can't make 5i any simpler, so I'm going to bring that down. I had to do one extra step there, so I'll just bring that down. That got simplified here, but again, I had an extra step there, so I'll move it down. Looking at negative 4i squared, I squared is negative 1, so negative 1 and negative 4 make positive 4. 3i cubed is negative I. Minus 3 and minus I make plus 3i. That one got simplified here, just bring it down. So, each thing got simplified, each thing took however many steps it took to simplify it, but each thing had its own simplification, had no bearing on anything else in the problem. The blue affected the blue, red affected red, green affected green, purple affected purple. All that work got us to this point, which is, this is our expression now that we're trying to simplify. And the problem, the reason it isn't simplified, is this term right here. That's our problem. We don't want I in the denominator. So the fix is simply we take 4 plus 3i over negative 2 minus 5i. We're going to multiply by the complex conjugate. That means we take the same exact expression as this, but we change the middle sign. Negative 2 stays negative 2, minus 5i becomes plus 5i. I multiply the bottom by that, I multiply the top by the same thing. On top it's FOIL. 4 times negative 2 is negative 8. 4 times positive 5i is positive 20i. 3i times negative 2 is negative 6i. 3i times 5i is positive 15i squared. On the bottom it's just FL. First times first, negative 2 times negative 2 is positive 4. Last times last, negative 5i and positive 5i is negative 25i squared. Okay. I recommend writing it with the i's and the real numbers and the I squared. Just everything, whatever the product is, let the product be what it is. Then 15i squared is going to be minus 15. Minus 25i squared is going to be plus 25. So we end up with negative 8 plus 15 is 7. 20i minus 6i is positive 14i. And 4 plus 25 is 29. And since we get imaginary, we're going to write it as separate fractions. There's our simplified version of that expression. Number 14, trying to simplify square roots or fourth roots, radicals in general of letters to powers. So this is a fourth root. That's y to the first power. So that's going to become x to the 3/4 power, y to the 1/4 power. You simply keep the bases what they are, power divided by root to create fractional powers out of it. The second one, this is a square root understood. That's a y to the first power understood. So again, the bases are x and y, 3/2 for x, 1/2 for y. That's job one. Get the letters out of the radicals, create fractional powers. Step 2, we're going to multiply the same letters, x times x. We're going to add the powers. So 3/4 is being added to 3/2. I went ahead and made a common denominator in the process. Looking at the y's, y is still the base, 1/4 plus 1/2. Again, creating a common denominator, 1/2 is the same as 2/4. So my final answer is simply going to be x to the 9/4, y to the 3/4, the end. Change into fractional powers, add the common bases powers together, getting a common denominator because fractions are involved. It's a pretty simple problem, but some of you are making it much more difficult than that. So pay attention to detail, do it in this process you're supposed to do it, and you'll be fine. Finally, number 15, we have a quadratic equation, solving it. So I'm going to start by moving the 6 to the other side. We always want quadratic equations to equal 0. So 0 equals 3x squared plus 7x minus 6. Now chances are this is a factorable quadratic equation, so if we do it by factoring, factors of negative 18x squared whose sum is positive 7x, that'll be 9x and negative 2x. And the way we factor a trinomial with a lead coefficient that is not 1, again, I got that by multiplying these two things together, and that's just the middle term. So, and I figured this out just because I figured it out, and it's a skill that you guys all possess. You've been doing it for a long time. I'm going to transform this one term into these two terms, and an order matters. So 3x squared, I'm going to go minus 2x plus 9x minus 6. Anytime we can get the third position term as a positive, it's useful, and 9x is positive, so I'm going to put it there. I'm going to factor by grouping, so what I'm doing is grouping the first two together and grouping the second two together, and because the third position term is positive, there's a plus in between the parentheses. Common factor in the first group is x. Common factor in the second group is 3. So now we have a common binomial factor, 3x minus 2, and we have greatest common factors of x plus 3. So then we solve each one of those individually. 3x minus 2 equals 0, so 3x equals 2, so x equals 2/3. X plus 3 is equal to 0, so x equals negative 3. So x equals 2/3, x equals negative 3, there's our answers. Now, the other option, once you get to the point where it's 3x squared plus 7x minus 6 equals 0, is the quadratic formula. Opposite of b is minus 7, 2a is 6. And if I do b squared minus 4ac, that's going to be 49 plus, two negatives make a positive, 72, which is 121. So x equals negative 7 plus or minus 11 over 6. Negative 7 plus 11 is 4. Negative 7 minus 11 is negative 18. 4 6 is equal to 2/3. Negative 18 6 is negative 3. I'm not going to specify a technique, so if you're good with factoring, there you go. If you're good with the quadratic formula, there you go. Give me the correct answer using a proper technique.